Jupiter, the largest planet in our solar system, is one of the most visually stunning celestial objects, especially when viewed through a telescope. Its iconic stripes, alternating bands of light and dark, have captivated astronomers for centuries. But what causes these stripes, and what do they tell us about the dynamics of this gas giant? In this video, we'll explore the science behind Jupiter's stripes, touching on its atmospheric composition, weather patterns, and planetary physics. By the end, you'll have a deeper appreciation for the forces shaping one of the most enigmatic planets in our solar system. The stripes on Jupiter, known as zones and belts, are created by the planet's dynamic atmosphere. These bands run parallel to Jupiter's equator and result from differences in the composition, temperature, and motion of its gases. The lighter bands, called zones, are regions of rising gas. They are cooler and composed primarily of ammonia ice crystals, giving them a pale, whitish appearance. The darker bands, known as belts, are regions of sinking gas. These areas are warmer and contain darker compounds, such as ammonium hydrosulfide, which contribute to their reddish-brown hue. The formation of these stripes is deeply connected to Jupiter's rapid rotation. Jupiter completes a full rotation in just under 10 hours, making it the fastest spinning planet in the solar system. This rapid rotation generates powerful jet streams in its atmosphere, which separate the zones and belts. These jet streams, flowing in opposite directions at speeds of up to 400 kilometers per hour, create sharp boundaries between the bands. This phenomenon is somewhat similar to the jet streams on Earth, but on a much larger and more intense scale. Another factor contributing to Jupiter's stripes is the planet's convection currents. Beneath Jupiter's visible clouds lies a turbulent atmosphere filled with hydrogen and helium gas. Heat from the planet's interior drives convection, where hot gases rise, cool, and then sink back down. In zones, the rising gas carries lighter-colored ammonia ice to the top, while in belts, sinking gas reveals darker materials. This continuous movement creates the striking striped pattern we see from Earth. Jupiter's atmosphere is also influenced by its immense gravity and lack of a solid surface. Unlike terrestrial planets like Earth or Mars, Jupiter is a gas giant, meaning it is composed almost entirely of gases and lacks a solid crust. This allows its atmosphere to extend deep into the planet, creating layers of complex weather systems. The lack of a solid surface means there are no geographical features to disrupt the jet streams, allowing the stripes to remain relatively stable over long periods. Interestingly, the colors and patterns of Jupiter's stripes can change over time. These variations are caused by changes in the chemical composition and cloud cover of the atmosphere. For example, astronomers have observed shifts in the color intensity of the belts, as well as temporary disruptions in their structure. These changes are thought to result from large-scale weather events, such as storms or waves in the atmosphere. Jupiter's famous Great Red Spot, a massive storm larger than Earth, is one such feature that has interacted with the planet's stripes. The exploration of Jupiter's stripes has been greatly enhanced by spacecraft missions like Voyager, Galileo, and the more recent Juno mission. NASA's Juno spacecraft, which has been orbiting Jupiter since 2016, has provided detailed images and data about the planet's atmosphere. Juno's instruments have allowed scientists to measure the depth of the zones and belts, revealing that these patterns extend hundreds of kilometers below the cloud tops. This suggests that Jupiter's stripes are not just surface features but are deeply rooted in the planet's atmospheric dynamics. Jupiter's stripes also provide valuable insights into the physics of gas giants beyond our solar system. Many exoplanets, particularly those classified as hot Jupiters, exhibit similar banded patterns. By studying Jupiter, scientists can develop models to understand the atmospheres of these distant worlds, shedding light on their composition, weather, and potential habitability. In summary, the stunning stripes of Jupiter are a product of its dynamic atmosphere, rapid rotation, and unique composition. These bands, formed by rising and sinking gases separated by powerful jet streams, reveal a planet of incredible complexity and beauty. They remind us of the intricate interplay of forces shaping the planets in our solar system and beyond. Jupiter's stripes aren't just a visual treat for astronomers, they're a gateway to understanding the fundamental processes governing gas giants. So, next time you look at an image of Jupiter, remember that those mesmerizing bands are the result of a planet-sized dance of physics, chemistry, and meteorology. If you found this exploration fascinating, don't forget to like, subscribe, and hit the notification bell to stay updated with more exciting astronomy content. What do you find most intriguing about Jupiter? Let us know in the comments below.